In this case, we're going to be looking at a solid object and it has a weight, which is mass times gravity. So the center of gravity, the center of gravity of any solid is a point, can you see, or a line that passes through the center of the mass of the solid. So you can see here, this is the weight of the center. So the center of gravity is called the center mass. Sometimes they call it CG, which is the center of gravity. So we have been dealing with lamina, and with lamina, the thickness and the mass is small, so it was neglected. But with the areas of solid shape, you can see here. These are the formulas for determining the centroid. It's the same thing. You can see for cylinder is h/2, and then that is for cube, that is for a sphere, and that is for a cylinder. And then if it is a cone, this is the CG, the center of gravity of a cone. So the x and y coordinate there. So the y there is going to be h/4. And then when you are dealing with a semi-sphere, of course, this is a solid. You can see the CG is there. The x and y coordinate of the CG is this. So the y is what? 3/8 multiplied by the radius. So the radius is the distance from that point. That's the radius of the semi-sphere. So how do you do calculation in this? If you are to calculate the coordinates of the center of gravity of a solid. So like I said, most of the time we don't normally have question coming out in this aspect. So there is a solid here that is given, and if you check this solid, you will realize that it has two shapes. It has a cone, and then it has say the first part is a cone, and the second part is the semi-sphere. The top part is this side here, which is the 2. This is the semi-sphere, and the first part is a cone. Okay, so with this one here, you can see how it is. So I'm going to come here and write parts. Here I'm going to use table. I'm going to be using volume here. Remember, we're using area because here we are dealing with a solid. We are going to be using volume, and then we're going to be determining the coordinates of the x and y of each of the parts. So the first one there is the cone. Cone and semi-sphere. So with the cone, what's the volume for calculating a cone? Is pi 1/3. I think the volume for calculating cone is the volume of a cone is 1/3 pi r² h. For those of you that doesn't know, you're supposed to know that. So it's going to be 1/3 pi multiplied by r. The radius here is what? 32. Radius of the cone there is 32. The height there, that's 32 squared. The height there is going to be what? 80. Okay. I want someone to give me the volume of the cone. What about the volume of a semi-sphere? Okay, so you see the reason why questions are not always coming out of this. The volume of a semi-sphere. Can someone give me the formula for calculating the volume of a semi-sphere? Okay, for the cone is 85786.42. Okay, 1/2, half of 4/3. Yes, that is correct. That is correct. That is 4/6 pi r². 4/6 pi r². The radius is what? 32 squared. Guys, you need to know this. I think one of the reasons why questions doesn't normally come out the one of solid is because of the formulas of this area. So they can give you any shape. You need to be able to know the area. So what's going to be the volume of the semisphere? Is it pi r squared or pi r cube over 3 pi r? Is it pi r cube or pi r squared? I think it's pi r cube. So the area, the volume will be what? Others, please participate as well. It's just not only one student in class. Thank you. That's 68,629.14 is millimeter cube. Is volume. So how do we determine the coordinate, the x and y coordinate of the cone? So with the cone, with the cone is going to be, we need to calculate the CG of the cone here. The CG from this point to this point. Just wait, guys. Just want to insert some things here so that we'll be able to. I'm also going to draw another line as well that passes through the center of here. Just doing some analysis here. Hope you guys are with me. I'm also going to draw a line. You can see that line there. Okay. Now, if you want to calculate, so for the cone, I need to determine, I want to determine the distance between, wait, I want to determine the distance between this point and this point. You see, now because the CG of the cone is there, I want to determine that distance. So I have to subtract 80 from something. So this distance here, let's check for the cone rather. Let's check the formula is h over 4, isn't it? And you see that the y, and you see that it's h over 4. It's going to be h over 4. So that distance there is going to be h over 4. That is going to be h over 4, which is the height. It's going to give us what? 20. So that distance there is going to give you what? It's going to give us 20. This small distance here is 20. Okay, so it's going to be 80 minus 20 is going to give us 60. You see, it's going to give us what? 60. So the x coordinate is what? 60. The y, of course, is constant. The y is what? 32. So it's from the x-axis to the center. For the let's do for the semisphere, the x-axis for the semisphere CG will be around here. CG for the hemisphere will be around here. So I'm just going to insert another line here. Okay. Put more weight there. Yes. Trying to put all the details there so that you understand what I'm doing here. Okay, so this is the CG of the semisphere, right? So it's going to be 80 plus, we need to calculate this distance here. So let's go to the semisphere formula. That is 3 over 8. You can see that the y is 3 over 8 r. 3 over 8 what? R. So that distance there is 3 over 8 is going to be 3 over 8 r. So this is going to be 3 over 8 multiplied by what? 32. So that distance there is going to be 3 over 8 multiplied by 32 is going to give us what? 12. That is correct, Jonathan. So you're going to add 80 to 12. So it's from the x-axis to the center. 80 plus 12 is going to give you what? 92. That's correct. And then that is the x, and the y is what? Is 32. Any questions here, guys? Any questions? Do you understand what I did? All right. Can someone give me the value of the total area? Just punch the value and just call the value for me. Thank you. 154,415.56 millimeters squared. So the rest is easy. So our y bar, guys, is automatically equals to what? 32 millimeters. So you can see we have a straight line that passes through. If you see that broken line there that passes through the center, let me change the color. Change the color to, let me use, so you can see. So that distance there is what? Is 32. So you measure to the what? So that distance there is what? Is 32. So this is 32. Remember for the laminar that we did, that one is for X, but this one, because the blue line passes through, that's the center, it passes through the center of the cone and the semisphere. Y bar is 32. So let's determine the X bar is the one that we want to calculate. So instead of moment of area, in this case is the moment of volume, right? About the Y axis of rotation. So it's going to be the total volume multiplied by X bar equals to V1 X1, right? Plus V2 X2. There is no hole there, so we are not subtracting. So the total volume is 154415.56 multiplied by the X coordinates going to be equals to V1. Our V1 is 85, right? 786 multiplied by, guys, don't forget, this is your X1, Y1, this is your X2, this is your Y2. X1 is what? X1 is 60 plus V2, which is 68 what? 629 multiplied by X2, which is what? X2 is 92. Can someone give me the value of the X bar coordinate of that? Just divide everything there on the right hand side by the total area. By the total volume, sorry. Volume area is, I'm used to the area because of the laminar. This one is going to be volume. That's correct. The answer is 74.22 millimeters. So the X is 74.22, and then the Y coordinate of the center is what? Is 32. So that is going to be our answer. Any questions? So in this case, instead of us using area, we're going to use what? Volume, because it is a solid object. So, and instead of you to calculate the moment of area, here you calculate the moment of volume about the axis of rotation. Any questions, guys? So I'm going to give you a classwork and an assignment. The C, activity 4.4, question 1C and 1F. 1C and 1F. 1C and 1F. Guys, I have to go now. I'm not feeling well. We'll look at this tomorrow. Um, this C, I've seen this type of question before in the exam, and this F, C and F, guys. C and F, question C, C and F. This is C. I've seen this kind of question, I think, many years ago when they used to bring out questions on this aspect. C and F, question C and question F is going to be a classwork or an assignment. But if you can do it now, you can try it now. Question C, try question C now. If you look at this question as well, think if you look at this question, the Y bar is going to be 25 because you can see here, just want to give you a clue of what to do here. So you can see that there is a line that passes through center. There's a straight line that passes through the center. You can see it there. Okay, so there is a line that passes through the center. So you will do your measurement from this point to this point to the x-axis. So because the line passes through we actually have 3 cylinders there. Let me just give you a clue. We'll look at this tomorrow. We have cylinder A, we have cylinder B, and then we have cylinder C. And then they will both have the same Y bar coordinate, common Y coordinate, which is what? 25 millimeters. So the only thing you have to do here is to find the moment of volume about the Y axis of rotation. That's the only thing, so that you'll be able to get your what? Your X coordinate. So I want you to probably solve it by using the same way I solved this as well, by arranging it, by putting it in a table. So I'm just going to give you 10 minutes, and after 10 minutes, then we can call it a day. Do it in form of table, part, volume, coordinate, and then you arrange it. If you can get only this one, then we'll continue tomorrow. So I'm going to give you 10 minutes to solve this. And don't forget, you are going to use the formula for calculating the volume of a cylinder. Let me just write the formula there. The volume of a cylinder is pi r squared h. The diameter is given. The diameter is 50. X is 54.38. That is very correct, Jonathan. That's the answer is correct. I need more answers. I'm not teaching one student here, guys. All right, guys. I'll see you guys next tomorrow. I'll see you guys tomorrow. Practice the rest of the question. F is there. F is also a work for you to do. Only F. And then from there we'll move to hydraulics. Have a good day, guys.